Hi, I'm Nicola Wass. I'm the CEO of SOMO, a consultancy based in the northwest of England, and we use proven behavioural frameworks and concepts to better understand and ultimately to influence human behaviour. And today I'm here with Tanya Fosdick, who is Head of Research at Agilysys. And many of you will already know her from her work in road safety research and analytics, but also as a real champion of the need to evaluate interventions in road safety. So, together, we're going to tell you how Liverpool City Council is using behavioural science to reduce death and injury on their roads.
Before we do that, let's take a moment to remind ourselves how local authorities like Liverpool have traditionally tried to save lives on their roads. So, as most of you will be aware, the standard approach to road safety has often relied on three levers of change: education, engineering and enforcement. Now, obviously, enforcement and engineering take far higher levels of resource and time to implement, which is why local authorities tend to reach first for information and awareness raising campaigns designed to inform people of the risks and to persuade them to care about the consequences. Liverpool Council was no different, but it was becoming increasingly obvious to them that creating good intentions simply wasn't enough. They were beginning to realise that it's entirely possible for road users to understand risks and care about the consequences, but then they get into a car or step out onto the road and behave in a way that is the complete opposite of what they know and believe to be right. So when in 2018 Liverpool Council found out that they had the second highest rate of adult pedestrian casualties in the whole of the UK, they knew they needed to take a completely different approach. So they came to us to help them first understand that problem, and then secondly to figure out what it was that they were missing. One of the first things we did was to visualise the pattern of collisions in a heat map that identified the main risk areas for adult pedestrians in Liverpool. Now, as you'd expect, there is a large cluster of collisions in the city centre.
Hang on, Tanya, let's not talk about the city centre today. Why don't you tell them about the second problem areas? Because I think they're far more intriguing.
These ones.
Yeah, those ones.
Okay, well, these sites are situated on the outskirts of the city centre, and collisions here occur mostly in the daytime. But what is really key is that it turns out that if you're an adult pedestrian in Liverpool, you are far more likely to be injured in one of these types of location than in any other context.
So that was fascinating, and immediately we knew we had to find out a little bit more about what was going on in these sites. So we sent members of the SOMO team out to conduct some observations in each of these locations. Now, it turned out that these sites had several things in common. They were all local high streets intersected by 4 lanes of fast-moving traffic. And every single one of these locations had a pedestrian crossing, which appeared to be located on a main pedestrian desire line. And that's important because these crossings weren't in the wrong place. But for whatever reason, people in these locations were electing not to use the very things designed to keep them safe, the pedestrian crossings.
So just to hammer this home, here is a detailed map showing casualties at a crossing site in Liverpool. So the circles and squares represent people who have been hit on this site over a period of 10 years. The blue line in the middle shows the location of the crossing, and the two green lines are 30 metres from that crossing in each direction. So what it really shows is just how close the people were to that crossing at the time of their injury. Now, analysis of driver behaviour found that very few drivers were breaking the law, so focusing on drivers would have null or negligible effect.
So basically, we decided to take it in a different direction. And we hypothesized that if we could increase the number of pedestrians who use the available crossings in these areas of high risk, we should be able to see an overall reduction in the rate of adult pedestrian casualties in the city, which is great. But without understanding why people in such risky locations are not using these available crossings, we just wouldn't know how to change things. So I went back to Tanya and I asked her to see what else could she extract from the data.
So going back to Stats 19, I was able to cross-tabulate the postcode data from Stats 19 with other data sets such as IMD and Mosaic, which many of you will use. This allowed me to profile the levels of education, health, wealth and lifestyle of the pedestrians involved, helping us to really understand who it was we should be targeting here.
And Tanya's analysis also revealed that people being hit in these locations tended to live very close to the collision site. So now we not only knew a lot more about the environment, these hotspots, but we also knew some more about the people who were involved. And the key thing we learned from Tanya was that our pedestrian casualties were likely to be experiencing money worries and poor physical and or mental health. And that gave us really, I suppose, our first insight or clue.
So why is this important?
Okay, Tanya, you and I talk about this a lot, but you've heard about the two-system model of thinking or two-system processing.
Yeah, so it's a way of explaining how the brain makes decisions. System one, which makes up about 95% of our thinking, is fast thinking, where decisions are made unconsciously. And system two is the slow thinking process, where rational decisions are made based on logic.
Correct. So system one is the notion that the majority of our daily choices and behaviors are automatic. They're shaped by habit and the environment we're in. And I think this is actually quite a positive. I see it as a proactive attempt by human beings to anticipate the world they inhabit and to find ways to master it. So, for example, we work out what chocolate biscuits we like, we find the best route to the shops, how to ride a bike. And once we figure these things out, we can kind of forget about it, freeing up the mind to concentrate on other things.
So isn't it a bit like when Barack Obama says that he only tends to wear blue or grey suits, so he doesn't have to think about what to put on in the morning? You know, he's obviously got so much else that he was thinking about.
I knew
What suited?
I knew you'd come up with that one. Yeah, precisely. Automaticity frees up our minds to think about other things. So let's recap. System one. System one thinking is fast, it's intuitive, it's automatic and effortless, and it works really, really well in predictable, stable environments. But, and this is a big but, it's also far more prone to bias and error. Much more so than system two, which is slow, it's effortful, it's deliberate, and quite costly. It's quite mentally taxing, but it typically produces a more unbiased and accurate response. So when you and I are really well rested and we're in good physical and mental health, we move fairly effortlessly between the two systems of thinking. However, when our cognitive load is greater, for example, when we're stressed, we're tired, we're hungry or unwell, as many of these pedestrians may be in these locations, then the amount of cognitive bandwidth available to us decreases. And when that decreases, that in turn reduces our capacity for the kind of effortful thought required to use system two. So put simply, the people in these locations are less likely to engage their system two processing and more likely to rely on system one, which is making them more vulnerable to error. And we all know that small errors on the road, complex, fast-moving environments can have disproportionate impacts. So I think what's really interesting is when we tie this all together, we can also infer that those traditional information-based campaigns, so loved by local authorities that Tanya mentioned in her intro, are unlikely to be effective. So cramming even more cognitive load onto somebody whose capacity is already pretty overloaded won't help. In fact, it may even have a negative effect. So this led us on to our second insight. And this one builds on the first, so bear with me. Okay, so we've told you that it's likely that people in these environments are more reliant on the system one processing. And there is an interaction between this fast system one processing and another type of thinking, goal-oriented thinking. And when both of these are at play, then what people will tend to do is they will filter out all sensory stimuli except those that align with their own goals. And that can result in a phenomenon known as looking but not seeing. So remember, we hypothesized that if we could get people in these locations to increase their use of available crossings, then we should see a reduction in the high levels of casualties. But when we went out into these locations and we did ethnographic research and observed people, we inferred that the people here were goal-oriented, and their goal was to get from A to B in the fastest and most direct way possible. But in doing so, they may not perceive the crossing in their midst to be the best way to achieve that. And as a result, the crossing may appear in their line of sight, but they're simply not attending to the fact that it's there. So we had this insight and we wanted to test it. So when we spoke to people in these locations and we asked them to recount back their journey, and this is very recently after they'd taken it, to literally stopping people on the street, they seldom recalled seeing the crossing when they recalled the things that they'd seen and heard. And that kind of tells us that although these crossings would have been visible to them, they're maybe not even registering them. So they're looking but not seeing the crossings intended to keep them safe.
But surely, Nicola, in high-risk areas, a key goal of the pedestrians would be to prioritise and attend to the things that could facilitate safe crossing.
Well, yes, you'd think so. However, we're assuming that they're alert to the risk of being hit. They might not be if they incorrectly perceive the area as low risk.
But why on earth would they see these areas as low risk? So remember I mentioned earlier that an adult pedestrian in Liverpool is more likely to be injured in one of these types of locations than in any other context.
Yeah, but the people who live in these areas are not using your collision data, Tanya, to inform their risk. It doesn't mean they're not assessing risk. They're conducting risk assessment, but they're probably using a different kind of data. And that's based on their own lived experience, where they may never have been hit by a car on one of these local high streets, or indeed somebody that they know well hasn't either. And that leads us on to our third and final insight, the path well travel bias, which describes the human bias to incorrectly judge the environments they're very familiar with to be low risk. So remember, Tanya told us that adult pedestrian casualties in these locations tend to live local to the area. But also because they are local, ironically, they are less likely to view their own high street as dangerous. So to sum up, we had a number of insights that could help us understanding a seemingly illogical decision to cross a dangerous road unaided. People here incorrectly perceive these locations as low risk. They are operating on a kind of sensory autopilot, which is attuned to finding the fastest rather than the safest route. And in this state, they're not attending to the crossings in their midst. So information-based campaigns are not particularly going to be effective here. And just to sum up, our research journey started with data analysis to help us understand the what, where, when, how, and who of the problem. But behavioural science was then applied to unlock the reasons why.
So at this point, Liverpool realised that this work had far wider national significance. So we jointly applied to the Road Safety Trust for funding to develop and trial 2 nudge-based interventions. And we were thrilled to receive the largest research grant ever awarded to a non-academic institution. Now, we would have loved to have been here today to show you the embedded nudges and to share the results of those trials. But remember, we are operating in the physical world and we need to run our trials in normal conditions in order to determine effect. And because of COVID, we've really had to push these trials back to 2021.
Yeah, it's true. We can't share with you the nudges that we have created to embed into these environments, nor have we been able to run trials, and so can't share our findings. But what we can do, because we didn't want to come away and not share anything with you, is we can talk a little bit about the thinking we used to turn these insights into interventions. So Tanya, you've probably not been on a plane for a little while, but I'm guessing at some point you will have seen one of these, a priority boarding sign at an airport. And just tell me, what's your gut response? What do you think and feel when you see one of these signs?
So the people in those queues, in the priority boarding queues, are going to get some kind of better experience than the people who aren't they?
Yeah, that's right. Priority boarding is very effective at cueing people to notice and attend to the fact that there is a faster and more direct way to board the plane. Now, we can do something similar with the crossings if we can find a way to align these crossings with our pedestrians' intrinsic goal, namely to get to where they're going in the fastest and most direct route possible. So if we can achieve this, we should be able to recalibrate their scanning of the environment to attend to and to cause a desire, I suppose, to use a crossing that looks like ours. Okay. So to do this, first of all, we need to make those pedestrian crossings more salient. Crossings generally blend into the area. They're black and grey and they don't particularly stand out to pedestrians. What would work really well is if we can find visual cues and nudges that confer a sense of speed, flow, and pedestrian prioritization. So these aren't our designs, but these are starting points, and these are things that we kind of considered when we're looking at what we could do in those environments.
So wouldn't we just be tricking people here? The crossings are essentially the same, so you're just making them look as if they're the fastest route across the road.
Good point. So it's really important to point out that we're not in the business of tricking people. The visual cues that we eventually use will be matched by an improved crossing experience. So we're working with traffic engineers to reduce the wait time for pedestrians. And then we're going to tell them that we've done so. And by telling them after the fact that they've had a wait time that confers a sense of priority to pedestrians, we'll elaborate something called the elaboration likelihood model. Meaning that every time a pedestrian sees one of these crossings, they should associate that with a better experience.
So this all sounds great, but as you and I know, all of this will remain a best guess until we test these nudges in the environments where those problematic behaviours exist. Now, as many of you will know, my obsession with evaluation means that we need to ensure that these are robustly tested. So actually, we're going to test our nudges not just in Liverpool, but also in Hull.
Yeah, and that's really important to our head of behavioural science, Dr. Holly Hope Smith, who's really keen on the idea of replicability. So you probably haven't heard about this, but there is something known as the replicability crisis in behavioural science. And it's a concern that the results of prominent behavioural science papers are not replicated when repeated in further study. So giving false positives.
Yeah, because there's a danger we could end up solving a problem in Liverpool, but the solution we create may not be transferable to locations in other parts of the UK. So testing in Hull as well as in Liverpool will give us a sense of the scalability of these cost-effective interventions. Now, Hull was a great match. Lived there for 15 years, so knew the city really well. It has similar socio-demographics, a similar road network, and a shared problem. So if we can achieve a similar effect in locations which present these similar conditions, then we can have more confidence in the universality of these interventions and share them more widely with you guys.
I think that's kind of where this work becomes interesting, not just for Liverpool, but for the rest of the UK, Tanya.
Absolutely. But here we are, and we're out of time. So as we said, the trials are planned for 2021, and we'll be sharing our findings from the research in academic journals and at several conferences and knowledge sharing events.
But if you want to find out a little bit more than we've been able to share with you today, we have been blogging our progress on the SOMO website, so please feel free to go there. If this has whetted your appetite for using more insight-led approaches, Tanya and I have developed some training for non-behavioural scientists on how to apply this approach, and we'd love to hear from you. But otherwise, thank you for listening. We may be here next year sharing our results, or even the year after, I'm not sure. But enjoy the rest of your day and take care. Bye-bye.